स्टूडेंट्स, आज का वीडियो मेरा फंक्शनल एनालिसिस पर है और फंक्शनल एनालिसिस में ये नॉन लीनियर स्पेस पर है। टुडे माय वीडियो इज ऑन फंक्शनल एनालिसिस इन टॉपिक नॉन लीनियर स्पेस, especially continuity based on continuity and joint continuity. तो चूंकि since it is non-linear space, the first is a linear space and linear space are have a finite number of terms, finite dimensional linear space. So therefore, when we talk about any element of a linear space n, then it must have n tuples elements, n dimensional elements. So if a vector x is there, given there, then x must be represented as x1, x2, x3, xn, n number of elements. Theorem is let K be a non-linear space and F denotes C or R. K क्या है? एक non-linear space है और F जो है वो कोई कॉम्प्लेक्स नंबर और रियल नंबर को बताता है। ये कॉम्प्लेक्स और रियल नंबर जो F है, ये F आपका स्केलर क्वांटिटी है, स्केलर है का सेट है, यानी F एक फील्ड है which contains the scalar quantity, that is the any absolute number. Then the mapping F, here mapping is given like this, F from n cross n to n, such that jointly continuous में n क्रॉस n होता है, यानी ये प्रोडक्ट स्पेस है, खास के प्रोडक्ट मैट्रिक है, यानी प्रोडक्ट स्पेस इन ए मैट्रिक स्पेस इट इज प्रोडक्ट स्पेस. Then we take two elements, one from F n and another from this one n. Suppose x is the member of n and y the member of this n. Then this order pair, the mapping of this order pair xy is like x plus y. When we add two numbers, then this will give to one number, so it will go in the set n. So fxy is equal to x plus y. fxy is the xy is the member of n cross n, and its result fxy when we take mapping is x plus y. If we take another mapping G from a scalar, the product of a scalar field and vector space, a linear space, then one set is F, another set is N. F is the set of all scalar, that is F is field and N is vector space, and this mapping goes to a single set N, where N, it means the product space. This product space gives the result as a output as the element of N, which is defined as G alpha x is equal to G alpha comma x बराबर alpha into x, where alpha is the member of F and x is the member of N. Are continuous. Are continuous is jointly continuous. Why? In jointly continuous, we take two product space, and here they are taking x and y. So this is the product space. So whenever we define jointly continuous, then we take two numbers in order pair, which is the product, which is the member of product space, and we know n cross n is a product metric space, a product topological space. Proof. Let whenever we discuss the thing continuity in a non-linear space, then we must take xn, yn, these elements. Why? In continuity, we take a sequence of numbers, sequence of vectors. Let xn is the sequence of vectors of n, and yn is the sequence of vectors that n. There are two sequence of sets xn and yn. the sequence in n and alpha n is a sequence of G f. Alpha n is a sequence of f. Alpha n is a sequence in f such that xn converges to x and yn converges to y and alpha n converges to alpha. You take it as a equation 1. In continuity, we take a sequence of sets and take limit. If it converges to x, another also converges to a point y, which is the member of the set, and alpha converges to alpha. Now, for jointly continuous, we take norm of fxn yn minus fxy. This is the definition. And if this norm of fxn yn minus fxy is equal to 0, then we say that it is continuous. Now we proceed. Since fxn yn fxy is equal to x plus y, so fxn yn is equal to xn plus y with norm. Norm is defined here, so we take norm minus fxy is equal to x plus y. Now we summarize it. Xn minus x plus yn minus y, xn minus x plus yn minus y with norm. Now we know that the property 3 of the norm is norm of xn plus yn, and norm of x plus y is less than or equal to norm x plus norm y. So norm of xn minus x plus yn minus y is less than or equal to norm of xn minus x plus norm of yn minus y. This is the property 3 of norm linear space. This is the property of 3 of norm linear space. But we know it is given also that xn converges to x and yn converges to y. So fxn yn minus fxy is less than or equal to what? Fxn yn is equal to xn minus x plus yn minus y. Here we have written, but xn converges to x and yn converges to y. So xn becomes x minus x, yn minus y, yn becomes y minus y, y minus y is equal to 0, and x minus x is equal to 0. The 0 plus 0 is equal to 0. So norm of what we have taken this value, norm of fxn yn minus fxy tends to 0, or norm of fxn yn converges to norm fxy, hence it is jointly continuous. Again, norm of first is, by first condition we have proved it. Now for second, mapping G f cross n to n, then we set f cross n. We take one sequence of f and another sequence of n. Here alpha n is the sequence of f, x sequence of sets in f. So alpha n xn, where xn is the member of the set n. So g alpha n xn minus g alpha x by the definition of joint continuous. But g alpha n comma xn, which is given as g alpha x is equal to alpha into x. So this one is alpha n xn, alpha n into xn minus alpha into x. It can be expressed in the form alpha n xn minus alpha n x plus alpha n x minus alpha x. Yani we add and subtract alpha n x in between. Now applying the n3 property, then the third property of norm linear space, the x plus y, norm of x plus y is less than or equal to norm x plus norm y. And we can adjust like this: alpha n xn minus alpha n x plus alpha n x minus alpha x which is less than or equal to, by norm 3 property, alpha n xn minus x. We take alpha n common. Alpha n is equal to alpha n xn minus x, right, less than or equal to alpha n xn minus x plus x is here common, so x alpha n minus alpha. We know that mode of alpha x, norm of alpha x is less than or equal to alpha norm x. So which can be written as alpha n and alpha n xn minus x plus x alpha n minus alpha, which can be written as mode of alpha n norm xn minus x plus mode of alpha n minus alpha norm x. A scalar quantity is represented in mode and vector quantity is represented in norm. Now alpha mode alpha n, and since xn converges to x, so x minus x is equal to 0, alpha n into norm 0 plus mode value of alpha n minus alpha, alpha n converges to alpha, alpha minus alpha is equal to 0, 0 mode of 0 into norm x, multiplying the norm 0 with alpha n, it gives 0. Similarly 0 into mode x equal to 0, so all are 0 as alpha n tends to n, alpha and xn converges to x as n tends to infinity. This implies g alpha n xn, norm of g alpha n xn minus g alpha x tends to 0, or norm g alpha n xn tends to g alpha x. It shows that this is the condition of joint continuous. This shows that f and g both are jointly continuous. This shows that f and g are jointly continuous. Thank you.